In this example, it comes in two parts. It pertains to the ADD converter. In part one, this part, I'm going to show you the hardware connections, and then in part two, you'll see the code that you have to write in the C language to collect ADD data and then post it somewhere. So again, the first thing we want to do is to think about the hardware and make the connections. So in the picture that you can see here, I have a 328 microprocessor, and it is connected to a LCD screen, which is in this case a graphics screen. It has 128 columns and 64 rows. So it is a 128 by 64 screen. It's black and white. And what we're going to do is we're going to collect some data, say temperature data, and then post it onto the screen in a graphical form, in a graph form. The other connections that you have to make here are that the V reference will be connected to 5 volts, and then your ADD signal coming from some sensor over here will go into one of your port C connections. There are 6 ADD converters on the 328. They are PC0 through PC number 5, PC 1, 2, 3, 4, and 5. In my diagram, I'm using PC0, the very first one. So to that pin, I connect an analog voltage. This voltage cannot exceed 5 volts, otherwise you could damage the chip. So we want to make sure that our signals coming from the sensor stay within 0 and 5 volts. This picture is showing a potentiometer that we could use. The potentiometer in this case has one leg connected to 5 volts and the other leg connected to ground. The middle connector from the potentiometer will be some value between 0 and 5, depending upon how you move the wiper, this little dial right here. And you can dial it all the way up to 5 volts, and you can dial it all the way down to 0. Certainly this doesn't represent temperature, but it would be very similar to perhaps a temperature sensor in the fact that you're getting a voltage out of it between 0 and 5 volts, and it does go to the ADD converter. So this here is a minimum setup, and you may want to construct this before doing something more complicated. The potentiometer can be drawn like this, where again on one end you have 5 volts, the other end you have ground, and the wiper will tap a voltage anywhere between the upper voltage and the lower voltage as you move that wiper up and down. Another way to construct this sort of sensor is in the picture shown below. For example, if you have a sensor that is resistive, in other words, as let's say the temperature changes, the resistance changes. These are called thermal resistors. And so again, the resistance is dependent upon the temperature. This has just 2 connections for the thermal resistor. So what you would have to do, because it doesn't look like this one, what you need to do is to get another resistor that's fixed, and its value would be the average value of your sensor. So if your sensor went up and down from, let's say, 9,000 to 10,000 ohms, then I would get a fixed resistor of about 9,500 ohms and put it here. And then from there go to 5 volts, and here go down to 0. So in the middle here, the voltage, let's say this is 9,500 and this is 9,500. The voltage off the tap middle would be half of 5 volts, or 2.5 volts, going into your port C bit number 0. As the resistance goes up and down, so will the voltage here. So this construction is slightly different than using a potentiometer, although they're very similar. There are many sensors that are resistive that would fit into this category here. If you are using a potentiometer, of course you want to use this configuration. There are some temperature sensors, like the LM35, which produces a voltage given a temperature. So it's not resistive, it will give you a voltage directly when it's in the environment to measure the temperature. So there is no need for a second resistor. You simply take the sensor, put 5 volts here, ground there, and it gives you a voltage. That voltage goes right to port C bit number 0. I would like to go back to the this picture here, where we have the fixed resistor and the sensor in this configuration. This is a voltage divider configuration. We know that the output is going to be somewhere between 5 volts and 0 volts. More specifically though, the equation for the output voltage is this one right here, which is 5, which is your source up here, times the fraction of the top resistor, the bottom resistor here, the RS, divided by RS plus RF. And from this equation you can predict what your output voltage will be. Next, let's remove this, and we're going to take a look at what it would look like when you actually have these parts in your hand. So with the equipment that we have, you can see that I have attached a graphic screen to our green board. There's the graphic screen. Notice the adapter. Notice the port that it plugs into. This screen runs off of 5 volts, so we want to make sure that we have the 5 volt jumper selected, which is right over here. And then the last bit that I need to do with this to make it work is I need to connect my V reference. So here I've got, well, I had a long wire, that's the best I could do. I don't have any short ones, but this wire here connects the V reference, which is right here, to 5 volts, which is right over there. Then I also needed to connect my PC0 right here, which is right there again. And it goes to, in this case, a potentiometer, this one. And this potentiometer is being tapped in the middle, going to PC0. On the outsides of the potentiometer, at the bottom and the top, we have a 5 volt wire here, and this wire here, the black one, goes to ground. And that's all you really need for doing this particular experiment.